I wanted to talk about how to approach the bomb programming assignment. It can be kind of difficult. It's a little daunting on how to even get started. So this tutorial is kind of help you show you what the files, how to think about it, how to approach the problem, and then also how to solve the first phase. First thing you want to do though is go to the page for on the class website and read it. I know we hate reading, and it can be kind of annoying. You just want to jump right into it, but I encourage you to read it. It will show you how to solve some of these problems that you'll be facing, how to think about it. It's really helpful, especially the hints. So please do read over this carefully. In fact, that's kind of what I'm going to be going over today. So it's not something I created. I'm just really following what this, what we're showing you here on the website. And there's some resources. These are helpful. Take a look at these. These will be valuable as you try to solve the phases in this program assignment. Okay, so once you've read that over, the next thing you need to go to is Learning Suite and click on the bomb program assignment. And there'll be two pages. One of the pages will be to download the bomb. Let's go ahead, you can type in your net ID, hit submit, and you'll download the bomb. Now this is a unique bomb. It's only for you. It will be randomized. So every bomb is going to be a little bit different from everyone else's. So be careful of that. Unless you know what you're doing, don't download more than one bomb, and unless you messed up a bomb or you don't want to use that one anymore, then only download a bomb then. But don't just be downloading on different computers and solving each one differently, because you only get credit for the one that you solve completely all the way through. Having said that, though, part of this is if you explode the bomb, you will lose points. Not many points, just a half a point per explosion of the bomb. So not much, but that might bother some people. If you do ever explode the bomb, you can always then go and download a new bomb and finish that bomb all the way through. But I will warn you, that bomb will be different than your previous bomb, so you'll have to solve more problems. Once you get good at it, it's not that much harder, but that is a word of warning. I'll show you ways in which you should never have to explode your bomb if you're careful. So it shouldn't be a big deal, but if for some reason you do accidentally explode a couple of times, then you can always download a new bomb and start over from there. So go ahead and download it. The other thing I suggest is that you don't download this on your personal computer. Download it from the digital lab computers. Now, these labs have to be done from the digital lab computer. You don't have to be physically there. You can SSH into them, but they have to be done on the computer. And so to start out, at least just for downloading it, it's best to be physically there at the computer, go to this website and download it. Otherwise, if you maybe are planning on SSHing into it and you go to this website, you might be on your personal computer, as I am now. And when you hit download, it'll download it onto your personal computer, but you can't run it on your personal computer. You have to then transfer it over to the digital computers. And that requires some extra commands. It's not a big deal, but it's just easier just to go into the lab and download it there. So make sure you do that. The next thing that you want to be aware of is the scoreboard. This is how you know if you got credit for it or not. Because if it shows up there, your bomb, then you know it's good. Now sometimes it has troubles loading. So let's try that again. Copy link. Let's try this one more time. Okay, it's having troubles. Yeah, there we go. Just takes a second. So this shows all the bombs. Who scored what. You don't know who has what bomb, but you'll know what bomb number you have, and then that can be what score you have and how many times you exploded it, and if it's valid or not. So this is what we're going to be looking at when we grade your assignment is the scoreboard and to see what score you get. So make sure you see your bomb here. Now I'll tell you I'm bombs 1. That's the one I downloaded it. So I've exploded a couple of times. It's not a big deal. I've lost 1 point because I exploded it twice. But this is where you can see where you're at. Okay, so let me SSH. So I've already downloaded it. I've already, as I said, I've downloaded this. I'm bomb 1. So let's SSH into the digital lab computers. Here's the kind of command to run. You would not put my net ID, but you'd put your own net ID. That's listed in these instructions right here on how to do that. I'm going SSH into the digital computer 15. Doesn't matter which computer it is. They're all synchronized, your home directory, so it can be any computer within the digital lab, or you can be physically sitting at the digital lab and bring up a terminal. It's up to you. But here we are. So let's go into my bomb1 folder and let's take a look at all the files. So first we have a README. Let's take a look at that. Nothing particularly crazy, just shows who it belongs to, what the ID is. Okay, cool. Then we have bomb. That's the first on the list, I guess. That's the executable. That's the thing you're going to be running and trying to type in commands. In fact, let's run it right now. So if I type in bomb, it's going to give me a little message, and it's waiting for me to type in the secret message. I don't know what the secret message is right now, so I can just type in, like, I don't know, test, see what happens. And I explode myself. Exploded the bomb. And if we go back to this page, we'll see it takes, it gets updated every 30 seconds. So look right there, I've exploded 3 times on this date. So that's all it takes to explode your bomb. You just type in the wrong command and it'll explode. So let's take a look at the other file, because obviously just running it and trying things is not going to work. So let's look at bomb.c. What's bomb.c all about? Got some kind of funny stuff right here, a little license, and got some funny notes. But what it is, this file, it's just the drivers, what they'd call it, the main file, the main main function for this bomb executable. You might say, well, why is this hard then? Like, what's if they give you main? The problem is we gave you main, so you know how it kind of all fits together, but we don't give you the phases. So you see there's this phase.h, so there's a corresponding phase.c. We don't give that to you. That's been already compiled into the executable, but that's not something we give to you. So the assembly's all there, but the C code's not there. So that's your job, is you need to figure out what these phases are doing. But it is helpful to kind of look through this and say, okay, it's going to initialize the bomb. There's 6 phases. Okay, here's phase 1. It's reading some input, and then it's running it, and then it's going to diffuse it. And then you move on to phase 2. So this is kind of helpful. And now I know some function names. Okay, phase 2, phase 1 are function names. That's could be helpful. That will be helpful later on. So that's it for the .c. If you ever have questions on kind of what's happening, how the pieces put together, then this is a helpful tool, but it won't tell you what the pieces actually are. Okay. So kind of going through this page right here, let's read up on some of these things. So like there's strings. Let's try that. This is a helpful tool. Strings, and then give it an executable. So our bomb. What this will do is it'll go through the executable and it'll find all the strings, all like the ASCII characters that are in an executable. A lot of them aren't going to make sense to you, but some of them might be kind of valuable. So we see some, different sections of our executable. Oh, look, there's something called read 6 numbers. That's interesting. Maybe that looks like a function name to me. There's like some sleep command. Can I go through this? Okay, phase 4, strings not equal. They're doing F open, and there's a main. So these are all like function names. If there's any strings embedded into your executable, then they'll be listed here. There's something called explode bomb. That might come in handy later. Different phases. So look over this, see what you see. There might not be anything that invaluable here, but there might be some interesting things. Let's see, anything else? Okay, looks like it's kind of interesting. This is maybe how it was run. It was using GNU C17. This is how it's compiled, I guess I should say. Oh, look, there's like some message, like good work. On to the next one. Phase 1 diffused. How about the next one? That's number 2. Welcome to it. So these are commands we've actually seen already when we ran this. So that's kind of interesting. Here's my net ID. Unable to connect to server. List of all the digital computers. So it can check. Oh, look, curses. You found the secret phase. Your structure has been notified. Interesting. Okay. We see a lot of strings right here. Welcome, UK, phase 1, fused. It's kind of interesting. What is this right here? I am the mayor. I can do anything I want. Okay, wow, you diffused the secret stage. Okay, so yeah, read through this. Some of it's kind of cryptic, but some of it is quite valuable. So that's strings. The other thing we can do is an object dump. We can just do object dump dash D, and then the name of the executable. And what this does, this just outputs it to the bytecode to assembly. It's converting it for us. So let me kind of walk you through what this looks like. Let me see if I can find something a little bit more main. Let's go here. So what's happening is object dump. This is actually what was in, these lines were in the executable. But everything else is just extra. Like this main right here and this address, that's just for us humans to understand. It's telling us what address in, or what offset within that file was main. And here's all the offsets, so all the addresses along the lines. And then over here, this column is all the assembly that these opcodes map to. All these binary strings, binary numbers map to. So this is not something that's actually, not all of this is actually in your executable. Really just this middle stuff is in your executable right here. And object dump is just converting it to us, for us to understand. Okay. So you can go through this and read it and kind of see what's going on here. For example, we see that it's reading a line and then it's calling phase one. It's calling phase diffuse. So we saw that in the main.c already. Or sorry, the bomb.c. So here we're seeing it in assembly form. That's kind of cool. Oh, okay, we see a phase one. That's interesting. Here's the phase one function. So we can go through here. Oh, there's a phase two. So this is the objective right here, actually, of the whole assignment is what is phase one doing? What's the right string we need to type in? So it's a little bit like detective work. You got to figure out, sleuth around and say, okay, well, look, there's this function called strings not equal. Okay, what is that? So let's do a search for that and see, okay, where's that defined? Okay, right here. And we need to start understanding what's going on. This is not a great environment, just through a text set or through, looking at it in statically. It's easier actually to do this with GDB. So that's what we'll switch to now, is GDB. So we type in GDB. GDB, you've used it before for a little bit in one of your labs for 225. It's a debugger. So it will execute run an executable for you. You can put breakpoints. You can stop execution. You can restart it. You can examine the registers or the variables, all sorts of things. Because we don't have the source code, we really are stuck with just looking at the assembly of it. So let's do GDB bomb. So this is telling GDB, hey, here's executable we want to run. That's not going to run automatically for us. It's waiting for us to actually run it. Let's do layout ASM. So layout assembly. This will show us the assembly. Let's do layout reg. This will show us our registers up here and our assembly down here, and the place we can kind of give commands to GDB. Now, GDB is kind of the OG debugger, and it's not super easy to use. It's all text-based. It's not graphical, but it's a good skill because sometimes that's just what you need. Okay. So let's see here. What should we do? Let's just run it. So we type in run, and that'll just go ahead and run the program for us. It gives us some extra information, but this is the same output we got before. Let's type in test. We know that's not right. Now I'm going to explode the bomb. So if you're following along, don't run this command. I'm going to hit enter because it's waiting for me. The program's waiting for me to hit enter. And look, I exploded the bomb and the program exited. Okay, so that's not great. But GDB is still up and running. It's fine with that. So let's not do that. Well, clear. Okay. Let's run this again. Layout ASM, layout reg. Okay. So we don't want to just go and run the thing without being careful. So we need to put a breakpoint somewhere. You can put breakpoints at function names. So let's do that. So what are some function names that we saw that might be important for us to put breakpoints at? Do breakpoint B for short. Breakpoint at phase _1. Pretty sure that was a function I saw. If you don't remember, you can go back to your strings or go to your bomb.c and that'll tell you. So there it worked. Now put a valid address. So now we have a breakpoint there. So it will run until it gets to that point. So now let's go ahead and run our program. Still asking us for a question. Let's do test. So now what we're seeing here is it broke right here. I'm sorry, this is a little hard to see. It's highlighted, but we have this B with this little caret. That means it's stopped right there. Has the list of all the registers. Now these should be familiar to you, these registers, right? You've learned about this for the last couple of weeks in 224. So they should have some meaning to you, these registers. So now it's just sitting there waiting for us to do something. So what we can do is we can do next instruction, and we can jump into things. We can examine what the registers are at given points in time. So we can do next instruction, NI. You don't want to do next. Next will be the next line of source code. That's a little too far for us. We don't want to go next line of source code. We want to go next line of assembly. So they call those instructions. So do next instruction. So I hit enter. Now look, it jumped down to the next line. Cool thing about GDB is if you just hit enter again, it'll run the previous command. So I can just hit it again, and it ran NI for me. Okay, so hopefully these look somewhat familiar. Here it's about to call a function called strings not equal. Now that seems like a very important strings, a pretty important function. So let's go into that. So the next instruction will just jump over function calls and go to the next instruction. We want to go into it. So let's do SI to step into next instruction. So SI, look, now we're in strings not equal. Sorry, maybe I should have clarified. How you interpret this is here's the address right here. And then here's the offset. This is helpful for us of like, you're in the strings not equal function, and you're offset by 4 instructions or 4 addresses. So +4, +6, +8, that's what the offset is from the beginning of that. That can be helpful sometimes. And then the end, the actual instruction right here. Okay, so let's keep going in here. So next instruction, cool. So it's going to call string length. It's going to call string length again. Okay, what's it doing? It's going to compare something. It's comparing. It's checking if it's not equal. Let's see. Okay, it's popping stuff off, and it's calling return. It's doing a test. It's going to jump. Okay, jump to explode bomb. Uh-oh. We probably want to keep going because I think that's going to explode the bomb. So what we can do is we can stop right there and say, okay, I'm done. And we can just restart it because obviously I typed something wrong. I didn't quite go into detail enough to really understand what's going on. So let's run it again. So we just type in run again. And you'll say, wait, you're in the middle of running. Are you sure you want to start over? Like, yes, I do. I definitely want to start over because I'm about to explode the bomb. So yes. So it's asking me, what do you want to type in? Okay, we know test doesn't work, but let's just type it in again anyways. So now we're at the breakpoint again. This happens sometimes. GDB gets all garbled up. Look, it's all kind of mess. You can hit refresh, and that will take care of everything for you. Up here, what this highlighted registers mean is that just got changed, those registers. So that can be helpful for you to know when an instruction caused something to get changed. Okay. So I would say it's worth it probably to put a breakpoint at explode bomb. So I don't ever want that to happen. If I ever, run past it for some reason, maybe I hit, continue, and I always want to stop explode bomb. So that would be my suggestion to you is always put a breakpoint at explode bomb. And if you ever get to that breakpoint, then start over. And then I put another breakpoint at whatever phase you're trying to solve. So phase 1 in this case. But you move on to phase 2, 3, 4, 5, 6, and so on. Okay, so let's actually figure this out. Now your bomb will be slightly different, but for phase 1, they're actually mostly the same, just the strings are slightly different. Okay, so let's go, next instruction. Let's think about this a little bit more. Specifically this strings not equal. Let's step into that. So what do you think that's doing, strings not equal? It's probably checking if 2 strings are not equal, right? I mean, that's in its name. But how would it get that information? That's kind of an interesting problem. What parameters do you think it might have strings not equal? It would make sense if it was checking if 2 strings are equal. The first parameter would probably be the first string, and the second parameter would probably be the second string, right? I don't know. That's just a guess. Let's try it out. Let's see. So what registers do we use when we pass in the first parameter and the second parameter of a function call? That's the question, right? Luckily, we have, there's stuff available online to help us with this type of thing. You should know this and go ahead and look at the slides as well. But this little handy, cheat sheet can tell us that RDI is used to pass the first argument into a function. Okay, and RSI is used to pass the second argument into a function. We don't know if this is what's happening, but it's worth a try. Let's see what's in RDI and what's in RSI. So go to RDI, and it's this right here, okay? Lots of 5s, BP 20. Okay, like let's see what's going on there. Like, what is that? That looks like an address to me. So what we can type in now is x/s. What is this? This does is let's examine some memory, and let's treat it as a string. That's what the /s is. And there's some helpful sheets on how to deal with that. What you put in x/, you can tell it whether it's read it as an integer or a string. But since we're typing in strings, and the fact that the function is called strings not equal, it's probably a string. So let's, if it's anything, so let's type that in, the address. So sorry, unfortunately copy and paste doesn't work. So 1, 2, 3, 4, 6, 7, 8, BB 20. Oh, look at that. Test. I'm the one that typed in test. Could be luck. Maybe I should rerun this again and type in something crazy that no one other would type in, like my net ID. But that seems oddly suspicious that the first parameter is the thing I typed in, so I think we're on the right track. So let's go back here. What is the second argument? It's RSI. So let's see where's RSI? Okay, right here. Let's see what RSI has for us. So typing the address that's referring to. 1, 2. Oh, interesting. Okay. I am the mayor. I can do anything I want. I don't know. That seems random enough that that's probably the answer, right? That's what I would say. So I typed in test. So it's going to check to see if test is equal to I'm the mayor. I can do anything I want. Those aren't going to be equal. So you know what? Let's just let's capture this off. So it's worth having some notepad up somewhere to, be recording some stuff because that is helpful. So I am the mayor. I can do anything I want. Now, should we include the quotes or not? I didn't type in the quotes, but it printed with here, so I would not type in the quotes here because I think that's just part of how GDB prints things out. It puts quotes around it. What's a string? Okay, so let's rerun this. Let's try it out. So I'm just going to type in run, I think R for short. It'll say, hey, are you sure you want to start over? Yeah, I want to start over. Okay. It's waiting for me to type in something. Let me go ahead and paste this in here. Okay, refresh. Let's do next instruction. I'm going to be greedy. I'm not going to jump into strings not equal. I just want to see what happens. So I'm going to just jump over it. Okay, it's going to test if EAX right here is equal to itself. Okay. It didn't jump. It's adding and it's returning. Look, we didn't call explode bomb because this jump, it would have jumped to phase plus 29. Phase 1 plus 29 is explode bomb. So we didn't take this branch. Instead, we moved on. So I think we're out in the clear. Let's keep going. Yep. Look, we got past phase 1. Now we're phase diffused. Can keep going. Okay. Awesome. Look, even printed out. Phase 1 diffused. How about the next one? Okay. So we figure out phase 1. That's awesome. Now on to phase 2. I won't be helping you with that, but you're going to follow the same process. Now, this is where it gets... You're going to mess up on phase 2. Let's say we messed up and we typed in something and we didn't want to. So we're going to call run again. Rerun. Run and say yes from beginning. We don't want to have to type in phase 1 again and again as we go to phase 2. And then once we figure out phase 2, type in phase 1 and phase 2. So there's actually a better way of doing this. So let's go ahead and exit out of GDB. Yes, I want to quit. Let's create a file called, so like Vim or Nano, that's Nano, okay, like solution.txt. What we can do is we can provide a file to BOM and it will go line by line for each phase. So line 1 is for phase 1, line 2 is for phase 2, and we can start putting our solutions in there. So if I go ahead and paste this in here and save it, yes. Okay, so now we have this file called solutions.txt or sol.txt. Let's go ahead and now use that. So we don't pass it in here. Normally you would pass it in like this, BOM, and then solution, but we don't want to do that because that could explode it. We still want to use GDB. So GDB, BOM, but you don't pass in the file. I'll show you where to pass it in. Okay, let's put our breakpoints. I'm really paranoid, so explode, BOM. I want to make sure that's the first thing I do right there. We're done with phase 1, so let's put breakpoint on phase 2. Let's lay out ASM, lay out reg. Okay, ready to go. It's called run, but now this is where you put the file name. So this is actually running it, and then you put the parameters as if you're running it. So when we do this, look, we said, oh, phase 1 is diffused. It took in that first file, the first line of that file, and passed it into phase 1, and it solved it. And so now it's, how about the next one? Okay, so we can type in on test. And now we're at the breakpoint for phase 2. And you can start looking around and say, well, look, it's calling a function called read 6 numbers. I wonder what we need to type in. Probably 6 numbers. And we can look in there even more to see, well, what's the format for those 6 numbers? How does this look? So at the end of the day, you're going to be essentially doing detective work. You're going to be figuring out what's going on. I would say you don't have to understand every single line of assembly going on here. At some points you might have to, but it can be kind of tricky. So start out with just like looking for the obvious signs. And then if you need to, start diving deeper. Like, I don't really care what's going on here. I have some intuition of what's happening here, but let's not worry about it. Let's just look at 6 numbers and see what's going on here. And is it passing them as parameters? What does it look like? And start understanding that. So hopefully this is helpful for you in solving at least phase 1. Your string will be different. Your 6 numbers will be different. Everyone's numbers will be different. So you can't, work together, but you can't give each other answers because everyone's different. Good luck. TAs are here to help you. I'm here to help you. Dr. Lee's here to help you. So, if you need any help, let us know. This is a tricky one, so don't feel bad if this is taking a long time or if you're feeling really confused, because this is a really challenging programming assignment. But I promise you, by the end of it, you'll feel amazing that you really do understand assembly. You know how it works. You can see how assembly maps to C code and vice versa, and you'll feel like really awesome, like a real hacker after solving this programming assignment. So good luck.